Welcome back to section 6.6, which is area between two curves. Today we're going to look at enclosing an area. So we're not going to give you the boundary points anymore. You're going to have to actually find those. When we talk about those boundary points, we're actually talking about the points of intersection. So you'll definitely need your graphing calculator for these problems. So I've got mine here. So the first thing we're going to have to do to be able to find that enclosed area is go ahead and graph so we can see what we're looking at. So we're going to go ahead and clear out anything I have in my y equals. I'm going to type in my 2x minus 1, my linear function there. I'm going to type in my quadratic, my x squared minus 4. I'm going to go ahead and graph those so I can get an idea of what it's going to look like. We should be able to graph it without a calculator. However, we have the calculator, so we might as well use it. Here's my quadratic, and then my linear function comes in something like this. So what we're going to do is be able to find, hopefully the C to start, that our area that we've enclosed is right here. And we're interested in this entire area. So we got to find, we'll call this A value, and we've got to find this B value, so that we can integrate it. So we should see that we're integrating from A to B of that linear function minus the bottom curve, which is that quadratic. So how do I find those points of intersection? Again, our calculator will do that for us. If we hit second trace, it will calculate our intersection, which is number 5. Moving the cursor down to our first point of intersection, we're going to hit enter a couple of times, and we see that it intersects at -1, -3. We're interested today in the x value of -1. We're going to do this again. We're going to calc number 5, but now we're going to move that cursor up so it's close to this point of intersection. And again, we're going to hit enter 3 times there, and we get the x value of 3. So we're going to be integrating from -1 to 3 of, well, we have our f of x is going to be our top curve, that linear function, so 2x minus 1, minus that bottom curve, which is x squared minus 4 dx. Now, if we remember in our y's, in our y equals, our y1 was 2x minus 1, our y2 was x squared minus 4. So again, we can use this calculator. If we go back to the main screen, if we do our math 9, we're going to go from -1 to 3. So -1, we hit 3. And now we can recall y1. Remember, that's in vars, y vars function. y1 is 1, minus y2. Again, vars, y vars function. And this time we're going to hit number 2 to get y2. And this is in terms of x. We're going to go ahead and hit enter, and we end up with a 10 2/3 as our answer. So that's going to give us that area enclosed between those two graphs. I have just a couple of examples again today. It should be nice, quick. Shouldn't be too miserable for us. So here we have f of x is x plus 3, and g of x is x to the third minus 3x plus 3. And we're looking for the area enclosed by these two graphs. So again, we're going to go to our y equals. We're going to clear out anything that's in there. We have x plus 3 as our first curve. We have x to the third minus 3x plus 3 as our second curve, if I would type it in correctly. So we have x to the third minus 3x plus 3. Go ahead and graph that function. Here comes our linear, and then, oh, isn't that interesting? Would you look at that? So here's that function. Notice what happens. So we come up, we come back down, we actually cross that linear function, and we go back up, and we cross the linear function again. So hopefully we see that we have two regions that are created by these two functions. So we're going to find the area of this region and the area of this region. Well, what is going to happen here? We're going to integrate from this value to this value. Our top curve is that cubic, but when we go from this point over to this x value, our top curve becomes the linear, our cubic becomes the bottom function. So we're going to go ahead and find the x values of all these points. We kind of see that it kind of looks like a -2, a 0, and 2, but we're going to make sure, just to double check ourselves. So again, we can second trace, intersect, we can come over for our first curve, get close to that with the cursor, hit enter 3 times, we do see it's a -2. Again, we're going to double check ourselves just to make sure, moving that cursor to our second point, entering 3 times, which is an interesting value. Mine came up with 7.383e to the -15th. And hopefully remember that if we're multiplying by 10 to the -15, that's a very small number. If we round to just a couple of decimal places, or a lot of decimal places actually, we're going to see it's going to be a 0. So it's kind of a erroneous value that they give us from the calculator every once in a while. But remember, that is just the value of 0. And then we come up here to get this third point. We're going to do this again. We're going to intersect. We're going to move that cursor, this time closer to that point of intersection. Hit enter 3 times, and we get the x value of 2. So what's this look like? Well, we have -2 to 0. Our top curve was that g of x. Remember, I put that into my y2. So I have y2 minus my bottom curve, which is going to be y1 dx. And to that, I'm going to add the integration. Now going from 0 to 2. My top curve now changes to y1 minus y2 dx. Again, in your homework, in your answer value, in your answers, I'm going to be looking to see you have the graph, just a rough sketch, and this integration equation. So I know that you know what you're doing. So I'm going to go back to my main screen, Math 9. I'm going to go from -2 to 0. Again, I can recall this y2 in vars, y-vars function, y2 minus vars, y-vars function, y1 dx. And to that, we're going to add the integration, Math 9, from 0 to 2. Now I'm going to do y1 minus y2. So vars, y-vars function, y1 minus vars, y-vars function, y2. Again, we're in terms of x, so dx. Hitting our enter, we end up with a value of 8. And that gives us the area enclosed by those two graphs. Again, I have just one more, a third example to end the day on. We're going to look at x squared, and we're going to look at x to the 1/3. So again, we're going to go ahead and type into the calculator. We have our x squared. We have our x to the 1/3. We're going to go ahead and graph those. And we should see this is very odd looking, and we don't really know what's happening in there. So in this one, we're going to have to actually change our windows. So I know that it's going to be very close in there. I'm going to change this from -10 to 10 to maybe -3 to 3. And same thing with my y values, maybe -3 to 3. So I can see a little better of what's happening with this graph. And look at that. So there we are. So here's my x squared. Again, this is in a very small area here. And then here's my x to the 3rd. So here we only have one area. And we're looking at this region here. So I need to know this value and this value. Again, it looks like 0 and it looks like 1. And we can go ahead and test that, second calc, intersect, all that good stuff. I know it's 0 and 1, so I'm going to remove that from having to see that. So we're going to go from 0 to 1. Our top curve is going to be that x to the 1/3 minus the bottom curve, which is x squared dx. Again, if we go to our y equals, x squared was y1, and x to the 3rd was our y2. So if we go back to our main screen, we can do Math 9. We can go from 0 to 1 of y2 minus y1. Or we could just type in x to the 1/3 minus x squared. This one is not really a big deal to go ahead and type it in. Probably be actually quicker if we did that. So x to the 1/3 minus x squared in terms of x. And we go and get an answer of, let our calculator work for a little bit. There we are, 0.4167 or 0.417. And that gives us an idea of what we're going to be able to do with our calculator and find the area of an enclosed region. Happy integrating!